Welcome to this video from Nanga Systems. In this video we're going to look at the capabilities and benefits that the Nanga Next Generation Deploy tool offers administrators of PTC Windchill Requirements Validation and Source, previously known as Integrity Lifecycle Manager. Windchill RV&S allows the free definition of a data model, also referred to as a process model or solution. The data model is designed to support an organization's process needs for application lifecycle management disciplines, as well as other bespoke processes, and is typically tuned to meet an organization's specific needs. The data model is a specific configuration of administrative objects, including item types, fields, states, queries, reports, projects, and workflow triggers. Over time, data models are changed as the organization's needs evolve, and this can present challenges in the administration of the data model. For example, in identifying and saving specific versions of a data model, comparing different configurations of a data model, or merging changes to data models for subsequent deployment to a Windchill RV&S server. The Nanga Next Generation Deploy tool provides advanced automated capabilities that support the export, graphical comparison, merging and deployment of Windchill RV&S data models. An XML file format means that configurations can be saved and versioned as they change over time, and can also be tailored manually before deployment to a Windchill RV&S server. Through a series of use cases, we're going to look at how the Nanga Next Generation Deploy tool supports exporting a Windchill RV&S solution, deploying a solution to an empty Windchill RV&S server, creating documentation for a solution process model, comparing two Windchill RV&S solutions and then deploying only the changes, and merging two solutions. This video is organized into chapters, one for each use case. At any point in the video you can display the table of contents using the button on the video controller and skip to a different chapter. In our scenario we have two Windchill RV&S servers, A and B. Server A is configured with a data model that supports the Agile methodology, while Server B is a new installation with no solution configured. In our first use case, we're going to export the Agile data model from Server A. This will give us the configuration in XML format, which can then be saved, versioned, tailored, and later deployed to Server B. Looking at the Windchill RV&S admin UI, we can see Server A on the left, with the Agile item types listed, and Server B on the right with no item types configured. The first step is to create an environment for Server A in the Nanga Next Generation Deploy tool. In the Environment tab, we enter an environment description and specify a directory to contain the environment data. On the Integrity tab, we provide the connection details for the Integrity server. And specify the path to the Windchill RV&S client installation. We can also choose to close the client session once an action has been performed using the Deploy tool. We can then check the connection to the server and save the connection details for later use. To export the solution from Server A, we connect to the Windchill RV&S server. Here we can load the previously saved connection details. And once connected, the export begins. The export of the solution can take several minutes, and a window displays the current activity with a progress bar. When the process completes, the exported solution is displayed in a new tab. We can navigate through the export by clicking on the nodes. If certain objects aren't required or relevant for our exported configuration, we can deselect them here. We can then save our exported configuration. For repeatability and consistency, Where objects have been identified as not required in the exported solution and so deselected, these solution settings can also be saved and subsequently applied to further solution exports. So now we have our Agile data model exported from Server A in XML format. If we want to make any further changes to the configuration, we can do that directly in the XML. Item presentation templates referenced by the solution can also be exported using the getTemplates function, which extracts the presentation templates identified by the item definitions to the environment templates folder, again in XML format. It then converts field IDs to field names and any host name references to a default value, making the template server independent. Finally, we can also extract the trigger files from the server to the environment data folder. Looking now in our environment folder for Server A, we can see the exported item presentation templates, and the trigger files. In our second use case, we're going to deploy the Agile solution that was previously exported from Server A to Server B. Server B is a new install with no data model configured. We'll start by creating a new environment in the Nanga Next Generation Deploy tool for Server B, again providing the environment information and the connection details. In the previous use case, we used the getTemplates function to extract the item presentation templates in XML format. This time we're going to use putTemplates to import the item presentation templates to Server B. The putTemplates operation can be run manually or automatically executed at the end of the deploy process. In this example, it will run automatically on completion of the deployment to Server B. First though, we need to copy the template XML files from the Server A environment templates folder to the Server B environment templates folder. In addition to the XML representation of the solution and the item presentation templates, other elements such as images, report recipes, trigger scripts and gateway mappings can form part of a configuration. In most cases, these files are stored in the Windchill RV&S Server data directory, and these files must be copied manually from the source server to the target server. In the previous use case, we used the getTriggerFiles function to extract the trigger scripts from Server A to the environment data folder, so we'll copy these now to the Server B data directory. The next major release of Nanga Next Generation Deploy will extend this feature to support the retrieval of all relevant files from the source server. To deploy the Agile solution to Server B, we use the Deploy option from the Tools menu and browse to the solution XML file previously exported from Server A. Optionally, a dry run can be performed whereby the deployment is simulated but not executed, and the commands that would be executed during deployment are written to a file. Under additional options, we can decide if we want to deploy or skip notification rules for users and groups. This offers the opportunity to prevent exceptions being reported during deployment, where notification rules point to items that are not part of the configuration, for example values in item-backed pick lists. With the checkbox disabled, the users and groups will be deployed but without configured notification rules. We can also choose to remove the temporary objects used by Nanga Next Generation Deploy during the deploy process once the process completes. In this example, we'll accept the defaults and click Apply to start the deployment. While the deployment runs, a window displays the current activity along with a progress bar. The deployment process can take from several minutes to several hours, depending on whether you're deploying a few changes or an entire solution. We'll speed things up a bit here for the sake of the video. The deployment operation only creates or edits artifacts, but doesn't delete them. Consequently, removing artifacts remains a manual procedure. Once a deployment is complete, any exceptions are listed in the window and are also recorded in a log file. In this case, we have some exceptions stating that the administrator, user and group couldn't be created as they already exist in the target environment, and so these can be safely ignored. We can now see the solution as deployed to server B, with the item types, the states, fields, trigger definitions, and other admin objects that make up the Agile solution originally exported from Server A. In our first use case, we saw how to export a Windchill RV&S data model in XML format. In our third use case, we'll see how the Nanga Next Generation Deploy tool can use this export to generate documentation for the data model. First, we'll open the environment for Server A, the server that we exported the Agile solution from. With our environment open, from the Tools menu we select Documentation and browse to the XML export. We can choose to create the documentation in HTML or PDF format. In this case, we'll choose HTML, and then click Apply. The solution documentation is generated and stored in the Environment Docs folder. As we look at the documentation, we can see each of the item types in our solution and drill down to the details for each one, in this case a user story, seeing the workflow state transitions, fields that are visible on this type, and other properties. We can also look at the field definitions used by this solution, grouped by data type, in this example integer fields. Also included in the report are the queries, trigger definitions, report definitions, test verdicts and other objects that form the solution. With the XML format used for solution exports, the Nanga Next Generation Deploy tool also supports comparing and merging of solutions. In our fourth use case, we'll look at comparing two Windchill RV&S solutions to identify the differences. We'll start by making some changes to the solution on Server A that was exported earlier in the first use case. In the admin UI, we'll add a description for the IBPL field Sprint Team. Add a default value for the field Sprint Planning Notes, and create a new state. Having made the changes, we'll export the solution again. As with the first use case, we connect to the Windchill RV&S Server, load the previously saved connection details, and once connected, the export begins. With the export completed, we'll save the exported configuration to a different file name in the environment folder. We'll now open the solution export from the first use case before the changes. And from the Tools menu we can select Difference to difference the two solution files. The difference results will always show what needs to be done to make the first selected file equivalent to the second selected file, and so we'll swap the order so that the changed solution appears second. Click on Difference and then Close. The results of the comparison are displayed in a third window, and we can click on the nodes to examine the differences identified as a result of our changes. Enabling the Show Items Containing toolbar, we can also filter an exported or differenced solution, allowing us to easily find specific objects by a text value, with case sensitivity if required, and showing or hiding content that has been added, modified, or deleted. We'll finish this use case by saving the differences to an XML file that contains only the delta of changes between the two solutions. In the previous use case, we generated an XML file that contains only the changes implemented between two versions of the Agile solution on Server A. In our fifth use case, we're going to apply these changes to the solution on Server B. The process is similar to our second use case, where we deployed the full Agile solution exported from Server A to Server B, but this time we'll use the XML file that contains just the changes. We'll start by opening the environment for Server B. We then select the Deploy option from the Tools menu, browse to the XML file created in the previous use case that contains the differences, and click Apply. As we're deploying only the changes, the process will be shorter. Again, we'll speed things up a bit here for the sake of the video. Once the process is completed, we can use the Admin UI to see the solution changes deployed to Server B. Firstly, looking at the changes to the two fields, and then the new state. In our final use case, we're going to look at merging solutions using the Nanga Next Generation Deploy tool. We'll start with a simple example to illustrate the functionality, using the environment that we've been working with, and then consider a scenario where this is applied to support the parallel development and integration of solution changes. In our first use case, we exported the Agile solution from Server A. We later made some changes and created an export containing only the differences. What we'll do now is merge the two exports to integrate the changes. From the Tools menu, we select Merge XML Files. In the Merging Differences window, we can load two or more XML files to be merged. We'll select the original export of the Agile solution and the file containing only the differences once the changes have been made. If identical objects, for example objects with identical names, are found in more than one of the XML files during the merge operation, the properties of the file identified as the master will take priority. In our example, we made some changes to the properties of existing fields, so we'll set the file that contains the changes to be the master. We'll leave the merge output file name and location as the default. If the checkbox Generate Detailed Report is set, the logging messages generated during the merge are exported to a file. These messages will also be displayed on the Summary tab. Clicking Next or selecting the specific tabs takes us through the different merge options. Under Groups, Projects and States, we can decide whether the merge process will concatenate MKS domain groups, workflows and documents groups, projects and states from all of the selected XML files, or take the values only from the master file identified in the previous step. Moving to the Queries tab, here we can adjust the merge options for queries. On the left, we can specify the unique identifiers for merge. During a merge, a query needs to have the same unique identifiers to be considered as a match. For queries, the name and the definition are always unique identifiers. To the right, we have additional options that can be added to the list of unique identifiers, which would then also be considered during the merge in identifying the query as unique. For example, if you have a query with the same name and definition in two XML files, but they have a different description, with only name and definition specified as unique identifiers, the two queries will be handled as the same object, and the result of the merge will be that a single query is stored in the merged XML file, with the query properties under additional options taken from the specified master file. If, however, we added description to the list of unique identifiers, this means that the queries will be handled as different objects, and the result of the merge will be that two queries are stored in the merged XML file. To distinguish the different queries, the second query will be named with the suffix #2, and in the case where more than two XML files are being considered for the merge, this naming convention continues #3, etc. For each object type, the merging rules applied for conflicts during the merge process are described in the Nanga Next Generation Deploy user documentation. Similarly, on the next tab, we can specify the unique identifiers for triggers. In the case of triggers, the trigger name and type are always unique identifiers. Rule and script name also default as unique identifiers, but can be moved back to the additional options list. On the Fields tab, we again have the field name and type as required unique identifiers, with editability, default, relevance and computation by default, which can again be moved back to the additional options list if required, while description can be added to the list of unique identifiers. In the case of a changed field name, by default the position of the field will be checked first and then the unique identifiers, but excluding the name. If all of these values are found equal and only the name differs, then this indicates that only the field name was changed, and that it isn't required to create an additional field. The Summary tab provides a list of the merge rules that will now be applied, and clicking on the Merge button starts the merge process. Any logging messages are displayed in the field Merge Results and Information, while a progress bar displays the current status of the merge operation. With the merge completed, we can take a look at the results. The merge text file contains the information from the Merge Results and Information window on the Summary tab. The Merge HTML report provides documentation for the merge solution in the same way as we saw in the third use case. And if we open up the XML output of the merge solutions, for the field Sprint Team, we can see the description added when the changes were made. For the field Sprint Planning Notes, we can see the default value that was added. And here we can see the new state that was added, all now merged into a solution file that can be used to deploy the integrated solution to a Windchill RV&S server. To conclude, we'll look at a scenario where the Nanga Next Generation Deploy tool is used to support the parallel development and integration of solution changes. In the scenario, we have a production Windchill RV&S server with an admin staging server, 3 separate servers used to develop solution changes, and a further server used for integration testing. The staging system is initially set up using a database copy from the production system. The Windchill RV&S solution is exported from the staging server using the Nanga Next Generation Deploy tool and deployed to each of the development servers. All development servers now have the same baseline solution. The development of the solution changes is then performed on these servers. Once the changes are complete, the modified solution is exported from each of the development servers, compared with the baseline, and the delta of change saved for each one. The changes from each of the development servers are then merged into one configuration. The merged configuration changes are then deployed to an integration testing server if required, and then deployed to the staging system to test the new configuration there. Once tested, the changes are finally migrated from the staging server to the production server, completing the development cycle. Thank you for watching this video from Nanga Systems. For further information on the Nanga Next Generation Deploy tool, please contact your nearest Nanga Systems office or email info@nangasystems.com.